Imagine having to peel an orange and lay it skin flat without tearing or distorting it. Sounds difficult, doesn't it? This is the same dilemma faced by cartographers when they try to depict our spherical Earth on a flat map. This is one of the topic of cartographic design. Map projection. In essence, a map projection is a method by which the curved surface of the Earth is represented on a flat surface. It's like a bridge between the three-dimensional world we live in and the two-dimensional maps we use. But here's the catch. No map projection can be entirely accurate. Why? Because it's impossible to transform a sphere into a flat plane without some degree of distortion. Think of it this way. Suppose you're trying to wrap a gift that's perfectly spherical. No matter how you fold the wrapping paper, you'll never be able to get it to fit smoothly without creasing or overlapping. Similarly, when cartographers attempt to flatten the Earth's surface, they have to compromise on certain aspects such as area, shape, distance, or direction. There are countless map projection systems out there, each with its own unique way of dealing with these compromises. And each of these systems preserves certain characteristics at the expense of others. For instance, some projections keep the area of land masses intact at the expense of distorting their shape, while others preserve the shape but alter the area. The Mercator projection, for instance, is well known for preserving direction. This makes it particularly useful for navigational purposes. However, it greatly distorts the size of land masses as you move away from the equator, making Greenland appear larger than Africa, when in reality, Africa is about 14 times larger. On the other hand, the equal area projection, as the name suggests, preserves the area of land masses. This means countries and continents are represented with their correct relative sizes, but it distorts their shape to do so. Equidistant projections preserve distances from a single point or along specific lines. These projections are useful for measuring distances accurately in specific directions. An example is the azimuthal equidistant projection, often used to show air travel distances from a central point. As one can see, each projection system is a compromise, a balance of pros and cons, and the choice of which projection to use depends on the objective of the map. To summarize, map projections are the cartographer's tool to transform the spherical Earth into a flat representation. In this process, some characteristics such as shape, area, distance, or direction get distorted. The type of projection chosen depends on what characteristic needs to be preserved for the map's purpose. It is a part of cartographic design, a blend of science, art, and decision-making, all aimed at helping us better understand and navigate our world.